Alright, good afternoon fellas. What we're looking at today is quadratic identities. And now there's some theory notes on iLearn for this. I'm going to suggest that you look at the notes as we're working through this. So the examples that I'll do here are the same as the ones that are in the notes, and it'll give you a bit more of an explanation as to how we're doing things. So if I skip some steps in the video, they are in those notes. But I'll try to take it nice and slowly because this is something that is often quite difficult to wrap your head around. So what we're looking at today is if we've got two ways of representing a quadratic function, or if we have two separate quadratic functions. Now we're just going to call those fx, function of x, and g of x. That's just another way of writing another function of x. If we say that they are the same or equal for all values of x, we say that they are identical, or they are identically equal. And that's how we write that. Now, the way these questions normally present themselves is that we end up with two different forms of a quadratic. So for example, we're going to look at here, we end up with something like 2x squared plus 4x plus 5 as one form, and the other form is a outside of x minus 3 all squared plus b outside of x minus 3 plus c. And what we're normally asked to do is find the values of a, b and c so that that is true. So this statement here is true. Now we're told it's true for all x. That's what this symbol here means. So now we've got to go find values of a, b and c. Well, where on earth do we want to get started here? We've got a few options, but I think the best option is we're going to pick some values for x so that we can go and form a couple of equations and solve them simultaneously. Well, the first thing I would stop and look and say is, alright, well, I'm going to, if I expand this out, and we're not going to expand it out, if I expand that out, I would get x squared minus 6x plus 9. Now I'm going to get x squared, x's and a constant there, and if I expand out this one, I'd get x's and a constant, and then again I'd get just a constant using that c. But the only place I'm going to get x squareds is from here. So whatever that value of, whatever that coefficient of x squared is, that's my value for a. So straight away I can just pick that one off. I can read that off and say, well, if I've got a only there, I know a is going to give me my x squared, so that means a equals 2. We've got one. One of our three is done. Alright, so we know that a is 2. How are we going to go about finding b and c? Well, to find the value for b, what we're going to do is actually, we're going to pick some values. Now we know that we've got 2x squared plus 4x plus 5, and that's going to be identical to a outside of x minus 3 all squared plus b outside of x minus 3 plus c. Now more often than not, these two are the same. So it's x minus 1 all squared and x minus 1. X plus 2 all squared and x plus 2. Sometimes they're not, but most of the time they are the same. Either way, start by substituting in that value into there. So what I mean by that value is whatever number will give me that bracket equaling 0, that's what I'm going to put in. So in this case, I'm going to let x equal 3. So now I've got to substitute that in on both sides of the equation. So therefore I end up with 2 outside of 3 squared plus 4 times 3 plus 5. That's all just a number. And that's equal to a outside of, well, 3 minus 3 squared is 0, plus b outside of, well, also 0, plus c. So we see here we're going to find our answer for c. It's just going to be all that. So c equals 2 times 3 squared, well that's 18, plus 12 plus 5 is 35. Okay, so we know in the back of our mind from previously that a equals 2 and c equals 35. Well, now we need b. Well, there's no easy way to find b. We've kind of done our two easy things. Two easy things are to pick off the value for a and then to substitute in that number that gives us a solution for those two brackets. After that, we've just got to pick a number that is close to that solution. So I'm going to pick x equals 2. Now you can pick x equals 4. You could in fact put in whatever number you would like, but really we want to put something in that's close to those solutions so we get nice, easy coefficients of a and b here. If we go and put in 10, we're going to have a harder simultaneous equation to go and solve. But it would technically still work. But my suggestion is to pick something. You could pick 4, for example, because then you'd end up with positive a and positive b. Whatever works for you. I think in the notes here I've put in both let x equal 4 and x equal 2. So it really doesn't matter which way you do it, as long as we pick something close to it. So if we put in x equals 2, we'll end up with, again, substituting it to the left here, 2 times 2 squared plus 4 times 2 plus 5. And that's going to be equal to a outside of minus 1 squared plus b outside of minus 1 plus, we'll see, I'm just going to put in that value for c, which is 35. So what I end up with here is, what's on my left? I've got 4 plus 8 is 12, plus 5 is 17, equals, minus 1 squared is, all squared is 1, so that's just 1a, minus b plus 35. Okay, so we've got an equation there. Okay, so what we've got is a minus b plus 35 equals 17. Now, in fact, that's an error. I just made an error on the previous side, so it should in fact say a minus b plus 35 equals 21. If you go and check the numbers on that previous slide, that will be correct. So I'm going to bring this 35 over to the right, so I'll end up with a minus b equals negative 14. Well, we could go solve simultaneously, but we already know that a equals 2. We know that a equals 2, so I end up with 2 minus b equals minus 14. And then my answer for b, therefore, is 16. Okay, so we've now found those values for a, b, and c. We should just go and rewrite it again. 2x squared plus 4x plus 5 is identical to, that's what that symbol means, 2 outside of x minus 3 all squared plus 16 outside of x minus 3 plus 35. Now if you did go and expand all this right hand side, you get the same thing. You get exactly what is on the left, but it's just a different way of representing that. Now the other example here, the second example I've got is express 2x squared minus 7x minus 4 in the form a x plus 2 all squared plus b x plus 2 plus c. Now again, let's do, I haven't put excessive notes on this one, but I do have the answers there for you. Again, we can just pick off a value for a because the only place I'm going to get an x squared is here. So I know straight away that a is 2. Alright, well let's go put in x equals negative 2 because again that will eliminate that one and that one. I'll just be left with c. That'll tell me my value for c. So therefore we're going to have 2 outside of minus 2 squared. This is going into the left. Minus 7 times negative 2 minus 4 equals, what's 0 plus c. So c is just going to be all this here on the left, which is what? 4 times 2 is 8, plus 14 is 22, so c will be 18. The value for c is 18. Well, let's go do the same thing again. I'm going to go put in, an easy one we can pick, let's put in x equals 0. Because that'll make the left nice and manageable, and we'll have some easy terms on the right as well. So I'd end up with 0 minus 4 equals a times 2 squared plus b times 2 plus my value for c is 18. Again, that comes from there. So I end up with 4a plus 2b plus 18 equals negative 4. So my 4a plus 2b is going to equal negative 22. Now I know my value for a here, don't I? I know a is 2 from previously, so therefore I can say 8 plus 2b equals negative 22, or 2b equals negative 30, and b equals negative 15. So again, let's get those answers down. A equals 2. B equals negative 15, and c equals 18. Now that's just a different way of writing that question. Express 2x squared minus 7x minus 4 in that form. Another way of writing, look, they're quadratic identities. They are identical to each other, so we need to go and employ this method to try to find those values for A, B, and C. All right, can we make sure we've got these examples in our notes, and we'll get into some work. Thank you.